Okay, let's give you guys some more practice. So here you've got a graph of y equals 1 over x, and we're going to revolve it 360 along the x-axis, So when you revolve it 360 degrees along the axis, the x-axis, you're going to trace out your 3D solid horn-shaped thing. Well, we've seen in one of the early videos that the volume, as it turns out, the volume will be pi for some strange reason. If you trace out if you rotate this 360 along the x-axis, the volume would be pi. Now my question here is the surface area. Will the surface area be finite? For the volume is finite. It comes to pi for some strange reason. But the surface area, will it come to a finite surface area? Okay, so remember the surface area would be given by this formula here, and we've seen this in the past. So remember the surface area is u summing up everything. So if you look at this one particular slice here, you need to work out this arc length. Well, the arc length will be given by this, and then once you've got your arc length, you need to times it by the circumference, which is 2 pi. Well, 2 pi the radius. The radius happens to be the height, which is 1. Well, blah blah blah. We've seen this before. Well, find out if the surface area will be finite, meaning will this thing converge or will it diverge? Okay, so press pause and have a go. Okay, so to do this, look, we need to work out the surface area. Well, looking at the formula for the surface area, we need to work out dy by dx. We need to obtain dy by dx. So we need to work out dy by dx. So looking at this, y equals this. So dy by dx equals this. So now we can put this into here. Don't forget we need to square it. So we need to square this. So when you square this, the surface area becomes this. So when you square this, it will then become this. So the surface area is given by this. Now this is a constant. So take it out. That will then give you this. So now it really boils down. So the surface area is given by this. So now it boils down to from 1 to infinity. Is this whole thing going to converge or will it diverge? So to answer that question, let's merge these. So here you've got one thing plus another thing. Let's merge the two together. That will then give you this. And then remember, if you have root a over b, that's the same as root a over root b. So basically, square root this, and then square root this. So that will then give us this. So now it's really top times top, bottom times bottom. That will then give you this. So now, so we are currently at this stage here. So let me just move this down here. Okay, so this is exactly the same as this. I'm just moving it down here. So now if you look at this here, so we've got the numerator over the denominator. If we omit this, if we discard this tiny bit here, we're making the numerator slightly smaller. So so now we're going to discard this thing here. So let's discard it. So that will then give you plus 0. So that will then give you this. Well, if you're making the denominator smaller, then the overall thing here will be less than or equal to this overall thing here. Because if you look at this and if you look at this, here we are discarding this tiny amount here. If you're making the numerator slightly smaller, then of course this whole thing here will be less than or equal to this thing here. So if you're discarding this, then this whole thing here will be less than or equal to this thing, because you're making the numerator slightly smaller. So that would then take us to here, and then now tidy this up. That will then give you this, and then tidy the whole thing up here. That will then give you this. And then here's something that you should recognize. This thing here, remember, this should be ingrained in your mind. A graph of 1 over x, 1, 1. The area from 1 to infinity, this area here will diverge. So this thing here will diverge. So when you times a constant, the whole thing will diverge. So if this thing here diverge, and this being smaller than this, then if you look at this here, this thing here is 1 over x. If this 1 to infinity, if this area diverge, this being greater or equal to, so if this thing here diverge, then this will have no choice but to also diverge, because this thing is bigger than this thing. Hang on, let me go back one step. If this thing here diverge, if this whole thing here diverge, this being bigger or equal to this thing here will have no choice but to diverge. This thing here will diverge. So hang on. So if this thing here diverge, hang on, if that thing here diverge, then meaning that if this thing here diverge, then the whole surface area will diverge. Meaning the whole surface area will diverge. Okay, so the final conclusion is that the surface area will diverge. Whereas if you look at the volume converges to pi for some strange reason. But then the surface area will actually diverge. Okay.